Welcome to Physics Knowledge channel. This is Junaidata. In today's lecture, I will tell you about the Newtonian gravity and Einstein general theory of relativity, and I will give you a brief introduction. We start from the Newtonian gravity when Newton published the law of gravitation and as three laws of motion. Then astronomers applied Newton law of gravitation to the solar system, and they get some very interesting results. William Herschel was an astronaut. He discovered planet Uranus by an accident. Uranus is the planet beyond Saturn, and when he discovered planet Uranus, he found something interesting that planet Uranus is not, it's showing some deviation, and now it they became confused at where this deviation is coming from, and they thought that maybe there is another planet beyond the Uranus, that gravity is tugging on Uranus, and due to this it is showing some deviation. And two mathematicians worked on this puzzle, and they worked on the equations of Newton, and they find that their calculation showed that there is another planet, and that planet is due to the that planet this Uranus is showing some deviation. And astronomers look at the sky, and they figured out that Neptune is the planet which is waiting over there in the sky, and they figure out that Neptune was the planet due to that the Uranus was showing the Uranus was showing deviation. It was a triumph of Newton's law of gravitation, that now people thought that it is not a law on this on earth, but it is becoming a universal law. And now when they apply this the same law into the Mercury is the planet near to the sun, and here they find the same result, that it is showing some deviation. And Newton has also shown us that the planet orbit in an ellipsis and not into the circular orbit. Instead of they orbit in ellipses. And from there the astronomers saw the same result, that Mercury is also showing some deviation. And then from here they apply Newton law of gravitation, then his equation become to break down. Why? Because Mercury is the planet near to the sun, and sun has a very strong gravity, and due to that gravity it was his equation do not describe the ellipse, the trajectories of Mercury. And then general theory of relativity came into play. When Einstein talk about the general theory of relativity, then the general theory of relativity is basically a geometry which describes the space-time is the curvature of matter and energy in it. And when these matter and energy combine, then they curve the fabric of space-time surround it, and every object then follow the trajectories of the greater mass. Now, the when Einstein show his equations, then his equations apply in very strong gravitational regimes. Then astronomers thought that Newton, we thought that Newton was right, but now another law of gravity came, the general theory of relativity, which is saying that the law before we thought that Newton was right, now it is wrong. No, it is not the way how science works. Since a Newton law applies on a small region where the gravity is so weak, but in general theory of relativity, the physicists, astronomers apply general theory of relativity and very strong gravitational regimes where the gravity is so strong. But even Einstein general theory of relativity do not show accurate result if you apply general theory of relativity and into the singularity of a black hole and the singularity at the beginning of the universe. Then as equation become to break down, then from there we need another law which is known as string theory. And string theory explains everything in it, and we have the topmost people, top brains which are working on this theory. But it showed it that science is something that when you do observations and when you show theory, then maybe in sometimes in some circumstances your this theory will be wrong because of the observations. When that first time William Herschel discovered Uranus, and from Uranus that they take the help of Newton's law, and from there they conclude that it is right, it is described by Newton law. But when we apply the Newtonian gravity into the very strong gravitational regime, then it is not showing any accurate result. Basically, general theory and a special theory of relativity. A special theory of relativity was also proposed by Albert Einstein, and it describes the motions of the object. But it was a small introduction about the Einstein and the Newtonian concept of the gravity, that simply Newtonian gravity applies on a very weak gravitational regime, and we apply the Einsteinian theory into the very high strong gravitational field.